Ask My Instructor 2.1.8. The position of an object moving along a line is given by this function, where t is seconds and s is meters. We are asked to find the average velocity of the object over different intervals, 0 to 6, 0 to 5, 0 to 4, and 0 to h. Recall that average velocity is just displacement over time. And we're going to need to come up with a formula in order to find the average velocity for our different time intervals. For the time interval 0 to 6, t0 will be 0 and t1 will be 6. Alright, so remember what s actually is. It's this function. And we're going to use the function in order to find the average velocity. Alright, well, s of 6, what would that look like? S of 0, well, that's 24. So the average velocity, I've written it out here without simplifying. So I could have pulled out a calculator, but what I want to do is I want to simplify that numerator. Again, I could just evaluate it, but I want to show you something. So I'm not going to actually evaluate it for a little while. Alright, I don't need the parentheses starting at negative 4.9 and ending at 24. I don't need those parentheses. It was just there to let you know that that is s of 6. So I just get rid of the parentheses. And notice that when I do that, I've got 24 minus 24, which is 0. Now, look at how there is a 6 squared and a 6 in the numerator, and then down in the denominator there's a 6. I'm going to factor out in the numerator, I'm going to factor out a 6. And then I'm going to cancel the factor of 6 that appears now in the numerator and the denominator. And so I get 3.6, which I could have found if I had just pulled out a calculator earlier. But I wanted to just kind of remind you, it's the beginning of the semester, and I want to remind you of how this algebra works. All right, so from the interval, the time interval from 0 to 6, my position at time 0 is 24. And my position at time t equals 6, we actually didn't calculate that. It looks like it's about 45. And the average velocity is 3.6 meters per second. I'd like to point out that the average velocity that we just found is the slope of the secant line connecting the points where t equals 0 and the point t equals 6. The problem plays out in a similar manner when we find the average on the interval 0 to 5. Again, I'm not going to use my calculator, but rather my algebra. I go 24 minus 24, and then I pull out a 5, and then I cancel the 5s. Regardless of how you do it, you will get 8.5, and the average velocity going from 0 to 5 is 8.5 meters per second, a larger number than we got before. Notice also, oops, let me back up. Notice also that the slope is a little bit more than it was, a little bit steeper than it was. Okay. Now 0 to 4, same song and dance. And this time I get 13.4, and my slope is even steeper. All right, so that begs the question, what happens as the time interval starting at 0 gets even smaller? For example, how about 0 to 3, 0 to 2, 0 to 1, 0 to a half, or wait a minute, that looks like 0 to 0.4. All right, to answer that question, we look at the time interval 0 to h, and we assume that h is positive because time is positive, right, in this case. Okay, so here's our average velocity, and because we've done the algebra before using numbers, the algebra using letters is going to be pretty easy. So here we go. I am going to subtract 24 minus 24, and then I'm going to factor out an h, and then I'm going to cancel the h, and I'm going to get negative 4.9 h plus 33 meters per second. So if I'm going from 0 to h, the average velocity will be negative 4.9 h plus 33 meters per second. All right, now that answers the question that you have for homework. Right now, I'd like to go beyond the question posed. What happens as h goes to 0? And this is going to be important in the next section. So if you don't want to listen now, maybe you want to come back to this video later. All right. What happens as h goes to 0? So what I did is I took that formula, negative 4.9 h plus 33. Remember, that's the average velocity from 0 to h. And I put in different values of h. I put in 6, 5, 4, 3, 2, 1, 0.1, and 0.01. And what seems to be happening? It appears that the average velocity, as that time interval gets smaller and smaller, the average velocity appears to be approaching 33 meters per second. And so if we had to guess, we would say that the average velocity on the interval 0h, well, this part is not a guess, so the average velocity is negative 4.9 h plus 33, but if we had to estimate the instantaneous velocity at the point t equals 0, well, we would just have h go down to 0 and we'd get 33 meters per second. And you'll see this theme in 2.2, this idea of taking a limit. All right, take care. Let me know if you have any questions.